Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is geek hates too many ones and it is a medium level problem. So if you actually read this problem is not very difficult and you will be able to do it very easily, similarly like the yesterday's problem, such that the topic it is from might be of medium level, but the problem itself is very easy. So it says that we have been given a non-negative integer n and we are only allowed to make the set bits unset, and we have to find the maximum possible value of the query so that after performing the given operations no three consecutive bits of the integer are set bits. So the problem is very simple. So if there are some like set bits together, like three set bits are together, then what we have to do is we have to make the rightmost bit 0. Now I just said we have to make the rightmost bit 0. The reason is because we want to make the total value to be maximum after it. That is why we would always want to make the least significant bit 0, right? Otherwise, we also have the option of making this bit 0, this bit 0, or this bit 0. We have the option of 3 bits. Making either of those 0 would satisfy our first condition, that is there should be no 3 consecutive ones, right? So this will satisfy the first condition. But now if we also want to make the answer or the remaining result maximum, then we will definitely have to make the rightmost bit, that is the least significant bit, 0, right? So the approach is pretty straightforward, that you would want to traverse from one end of the binary string, and then you just want to check if there are three ones together. You just have to make the rightmost one of them 0. Now the second question that comes to our mind is whether we have to traverse from the highest to lowest bit or lowest to highest bit, right? So this is the second question that is very important, and the order you choose might change your answer. So it is always optimal to go from the highest to lowest bit. The reason is because, for example, if you're going from highest to lowest, there are some bits here, and this is one. Let's say these are one, right? And there are some bits here also, right? So if you're going from highest to lowest and you find that like these three are consecutive ones, and you want to remove this particular last bit, right? So removing this bit will also help you remove these as a part of consecutive ones as well. So for example, if the bits were like this, right? So if you remove this particular bit, the middle one, then both of the groups are broken, right? Otherwise, what you'll have to do is if you start traversing from the right, you'll have to remove the bits one by one, and you'll have to eventually remove three bits. So let us take this example only. So if there are like this 1 2 3 4 5, right? So 0 1 2 3 4, right? If you start removing from the right end, you will have to remove this one, then this one, and then this one. Only then there will be two consecutive bits left. So this is actually equals to 7, right? So these three bits are equal to 7. But if you just try to remove this particular bit, then it will be equals to 4, right? So you're removing less value from in the second approach, where you were just removing the middle element, right? So this is an example of why like traversing from the left is always beneficial. Like this can be a counter test case for traversing from the back. So now you have already seen that traversing from the back is like no way better than traversing from the front, and you'll always have to traverse from the front, right? And the reason is the same, that whenever you traverse from the front, if you remove one bit, you have the possibility of breaking two chains of three consecutive ones. But if you remove from the back side, you only have the possibility of breaking one chain of consecutive ones, and in that way you will always have to remove more number of ones, right? So this was actually the solution of the whole question of today's problem of the day, and there is nothing more to it. You just have to, I'll repeat it again. Since we have to remove three ones, we can make either of them unset, and we want to maximize our value. So what we'll do is we will try to remove the rightmost bit. Now the question is, there are actually two traversal methods, one from the highest to lowest bit and one from the lowest to highest bit. So I've already shown with an example why traversing from lowest to highest is not as good as traversing from highest to lowest. So we will always traverse from highest bit to lowest bit, and in case of any three consecutive ones, we will remove the rightmost of them, right? So let me just show you the code now. So this particular problem, there are actually two ways of doing it. So let me just tell you that also. There are actually two ways of doing it. You can either use a vector on an array of size 32, right? And the other method is to directly make the changes in the binary number using like bitwise operators. Now I prefer this particular method, the array method, because for example, if you want to make the ith bit unset, right? So all you have to do is array of I is equal to 0, right? This is all you have to do. Whereas if you want to make the ith bit unset in the particular number n, like if it is an integer format, you'll have to do it something like this. So we'll have to take the AND of it with the, it should be I left shift 1, and then you have to take the invert value of this. So what will it will essentially do is, for example, if this is like this is the number n, and you want to make this bit unset, you will do, so this is 1 left shift I. I've written it incorrectly. There should be 1 left shift I, right? So what will happen is, if you do 1 left shift one time, so it will be here, right? It will be like this. Now if you invert it, it will be something like this, 1101, and you have to do the AND of these two, 1101, and you have to do the AND of these two values, so it will be equals to 1101, right? So this will be the way how you do it. So I really find that this method is far more straightforward, so we'll go with this particular method. So what I've actually done is I've created a vector of integers of size 32. Now for every like of those bits, I just find the bit value. So I'm just doing n right shift I and 1. So this is what I'm doing. If I'm trying to find the ith bit, value of ith bit, I'm just right shifting n by I and like doing bitwise AND of it with 1. So this will give me the value of the ith bit. If it is 0, it will return 0. If it is 1, it will return 1. Now I initialize my answer variable with 0, and for every bit starting from the highest order, what I just simply do is I just add like number left shift I into my answer. So if it is 0, the answer would already be 0. If the ith bit is 1, it will like add 1 left shift I to my answer, right? So it will automatically do that thing for me. Now if I is greater than 1, which means including the current bit, I still have 3 bits remaining. So I'll just check whether the ith and I minus 1 and I minus 2 bit are all 3 set. I'm just doing the bitwise AND. So if the bitwise AND of all these 3 bits, if it is 1, then I'll just make I minus 2th bit or the smallest of those equal to 0, right? And at the end, after the for loop is completed, I just return my answer. So this would be the solution of today's problem of the day. Geek hates too many ones. And as you have seen it, this is not a very difficult problem. It is an easy level problem according to me, but it's just that at easy level, you don't generally learn bit manipulation at first. So that is why they've included it in a medium level just because of the topic. So that was it for today. If you guys enjoyed this video, then you can consider dropping a like on this video. Also, if you are able to derive some values from these videos, then definitely subscribe. It's always free of cost. And if you don't like the content later, you can always unsubscribe. So please share this channel with your friends. Until the next video drops, keep coding, stay safe. Bye bye.